Hi everybody, my name is Sean Ray and I help customers make sense of and adopt emerging technologies. Today we'll talk about the exciting space of intelligent language processing. It combines a suite of machine learning technologies into a capability that is very useful for businesses of all sizes. Using three services we announced recently at reInvent. Amazon Transcribe, an automated speech recognition service. Amazon Comprehend, which allows you to gain insights from any document, transcript or article. And Amazon Translate, real-time machine translation that supports multiple languages. With the recent advancement of hardware and software, we are now in a position where we can process neural networks in near real time. This is at a time when video and audio are being generated at an unprecedented rate. From podcasts to conference calls, audio has become part of our daily lives. Likewise, video from TV to on-demand streaming and social media, we are consuming more audio and video than ever before. This data drives a complete shift in the way that we're going to access our digital systems and gain insights from them. But traditionally, audio and video are hard to index. They are hard to search. Gaining knowledge about your customers is increasingly difficult with the volumes generated. Companies employ people to tag all of this audio and video data, so they can apply coarse-grained searches, but you can't seek to a particular sentence or understand the key pieces of a speech. All of this information is locked inside, unable to be mined for insights. So how do we solve this problem? How do we get access to this information in a scalable and searchable way? The answer is that we transcribe it. The unstructured text space is very mature with technologies such as Elasticsearch. There are widely adopted indexing technologies and whole corpuses of training data. Not all transcription needs to happen in real time. Voice and audio recording is not a new capability. We have been interacting with call centers, writing court transcripts, recording lectures and generating massive volumes of audio and data for decades. But it's not just call centers. TV studios want to add captioning, subtitles and translation for their local audiences. Businesses want to record their meetings. Courts capture the proceedings through manual transcription. These then need to be searched in order for you to be able to look at how a decision was made in the past or who said what in which meeting. If you have social media, you want to engage your customers with the right advertisements. But how do you do all that? Because audio data is hard to process, and the solution is to transcribe it to text. Because once you transcribe it, you can get customer insights. We can increase access and have global reach by combining it with translation. You can target your advertising on social media and be able to search your audio and video archives. So today we're going to build a capability that solves these real-world problems. One you can use to get customer insights out of your own audio and video. First, we're going to be talking about Amazon Transcribe, a fully managed, continuously trained automatic speech recognition service that takes audio and automatically generates accurate transcripts. It has been designed specifically to work with the low-fidelity audio that is commonly found in call centers, where background noise can be high and audio recording equipment is of low quality. But in order to get the insights we want from our audio, we're going to need a few more features. It supports a wide range of audio, including high-fidelity recording and low-fidelity telephony. It is natively integrated with AWS Simple Storage System, or S3 for short. This allows you to use it as a data source for thousands of recordings. One of the key benefits that text provides us is the ability to search to a specific word, sentence, or paragraph. To replicate this functionality in our transcription service, we provide timestamps for every word processed, along with confidence scores that can be used by human quality control to amend any misheard words. In the past, when using this type of technology, it was common to receive a wall of text with no punctuation. It was very difficult to read and interpret. Amazon Transcribe is trained with this ability to use grammatically correct punctuation. We support two languages, English and Spanish, as both input and output. Well, let's say that you're reading a court transcript. Wouldn't it be easier to read if you could identify the speakers? Sometimes it is hard to ascertain if it's the lawyer, the judge, the defendant, or the witness speaking. We have built the transcribe service to automatically identify individual speakers and attempt to attribute the word, sentence, or paragraph to that individual, giving the transcript along with the punctuation a much more natural feel. In every industry, we have specific terms that we use, specific domain knowledge. Oftentimes, we use acronyms and abbreviation to describe common terms that are in common use. If I look at our own services, we talk about AWS, CDN, VPC, S3. To a layman, those acronyms mean nothing. To a certified AWS solution architect, they are recognizable as service names and capabilities. If you're in the finance industry, you talk about NPV and ROI. So we know that when people converse, this vernacular will creep into the conversation. It is impossible to train a generic system to deal with these nuances. To effectively help the machine understand this, we allow you to import your own custom vocabulary. These words and acronyms are given a higher weighting when the model is applied to your audio sources, allowing the machine to more accurately reflect what is being said. But I think that is enough about transcribe. How about we see it in action? First, we access the service from the AWS console, arriving on the transcribe landing page. Here, there is a list of features, some of which we just covered and a short description. For now, we are interested in transcribing some audio we have prepared. This audio was captured using Amazon Connect, our managed contact center platform, where Gabe, our APAC evangelist, is calling in to upgrade his plane seat to first class. This audio was captured by the system and placed in an S3 bucket. To begin, we enter the name of our transcribe job. In this example, Flight Upgrade 5. We copy in our S3 URL where we recorded the audio sits. Connect records its audio in WAV format, so we change the audio type. Finally, we can change the bitrate of the audio. However, for now, we won't touch this setting. We then click the Create button. And we can see that our transcribe job is in the queue and is now processing. We can see that several other jobs have been submitted to the queue. We can also click on our Flight Upgrade 5 job and see further details. At the top, we will have an output URL, which will provide us with our transcribe script once completed. We can also see the raw JSON output, showing us the job is still in progress. While we wait for the task to finish, let's take a look at the expected output. Our audio file is now being processed by the transcribe service. It will output a format similar to what is displayed on the screen. It will individually extract each word and provide a confidence score. The confidence score is out of 1 and will represent how certain the machine translation model is that this was the right spoken word. This is especially useful if you have a human who will go through and check the words with low confidence scores. For instance, in the media or news outlets, or maybe translation, where it is important to accurately depict the person being interviewed. The other detail you may notice is the timestamp. We can use the timestamp to seek to various parts of our recording by using the text that is captured. Okay, let's get back to our transcribe job and see if it's finished. We can see our Flight Upgrade Job 5 has completed and has a green tick, meaning the transcription was successful. Let's dive into the details and see what the output is. First off, you'll notice that the job state has changed to completed. You'll also notice the very long URL at the bottom, which is the transcript URL we can use along with the associated security token so that we can access the results in the future. You'll see that I'm highlighting the output URL. This is the URL we can use to access the JSON file. We can download this file to our browser. Normally you wouldn't do this, you would do it programmatically, but as we only have one output, we can look at the raw results and inspect some of the elements. Here we have our raw JSON file. It has a child for each of the words it has detected, as well as a confidence score. It also shows an alternative word if the confidence score was low. So now that we have this output, why don't we put it to good use? But what does all this text mean? How do we get insights from this huge JSON file? How can we make sense of it all? If we are transcribing large videos or thousands of audio calls, we need a way to search them all and look for commonalities, to understand if there are trends beginning to form in the business, or in our customer base that we might want to react to. This is where Amazon Comprehend shines. Amazon Comprehend, which is a fully managed natural language processing service, without ever having to provision a single server, Comprehend can understand documents and social networking posts you have collected. Any other data in AWS can be used, and you can simply provide the data that you're storing in your data lake in S3 via the Comprehend API. Comprehend uses natural language processing to give you highly accurate information about what it contains in 4 categories. Entities, which are really people and places, and dates and brands. Key phrases that add significance to the language. We also automatically detect what language is being used. And then the sentiment, whether or not people are feeling positively or negatively about the content. I'll give you a practical example. Hotels.com, which is an entity of Expedia. They have thousands and thousands of customer views and comments on their various hotels that people have stayed in, and whether they liked or didn't like that stay. Before, it just looks like this big blob of data. It's really hard to pull out what matters and doesn't matter. And so they're using Comprehend to understand what are the unique characteristics that people really like about each hotel, whether it's that they have a great dinner menu or great bathroom features or whatever it is. And what do they not like, so that when they're making recommendations to their users, they have the right way to differentiate and distinguish each hotel, so people can make the right choices for themselves. The other thing that Comprehend has, which you won't find anywhere else, is the ability not just to look at a single document at a time, but to look at millions of documents in order to identify the topics within these documents. It's something that we call topic modeling, and it's incredibly useful if you think about it. If you're a publisher with thousands of articles, it makes it easy for you to just, with one topic model, to figure out how to show just the business articles to the customers you think are interested in business, or just the political articles to the people you think are just interested in politics. Or if you're a healthcare provider, you may want to group all these documents based on the diagnosis or based on symptoms. This is a much easier way to understand what is in your data and then group them in a way that you could actually display news that's useful for your customers. Comprehend does this in an incredibly effective manner. Just to give you an example, if you tried to take 300 documents, each about a megabyte in size, Comprehend can build a topic model in just 45 minutes. That is incredibly useful when you think about it. It completely changes the meaning you can get from your content. So let's get back to our flight upgrade scenario. Why don't we use the power of Comprehend on our transcribed call log and see what insights we can gather. First off, we select Amazon Comprehend from the AWS console. We are presented with the services page. There is an example already present that we want to clear, so we'll highlight this text and we'll clear it out. Then we want to inject our transcribed results into the Comprehend service. You'll notice that the language is automatically detected down on the left-hand side. Now we click Analyze. This is where the entities, language, and sentiment will be extracted. We can see that Comprehend has identified our evangelist Gabe as a person with a very high confidence score. Next, we have detected that Sydney is likely a place where this conversation is either taking place or we are trying to do an action in the future in Sydney. We have also detected that we want to take this action tonight. And finally, we have detected that we want to upgrade to first class, but we don't have a very high confidence score on this attribute. We can now look through the key phrases. This will help us establish intent. Here we can see that we want to upgrade our flight to first class. The intent we are upgrading is a seat. We also detected this person is a platinum member, which we can feed into another system to gain more customer insights. As part of our analysis, we know that the dialogue is in English. And finally, we have analysed the sentiment of the transcribed audio, with a 63% confidence level that this interaction was a happy one. At this point, we could take this data and feed it into another system, gather more call recordings to see if we can spot trends, or perhaps return the raw feed to itself and manipulate it further. Perhaps we could tackle a big problem we encounter here in APAC, the language barrier. To help us do that, we have enlisted the help of Amazon Translate, which automatically translates text between languages. Translate is a great use case that requires real-time translation. There are things like live customer support or business communication with social media. You can translate entire bucket at one time. In our batch operations, it was very scalable. You will see in the coming weeks we're going to be able to recognize the source language on the fly, so you don't even have to specify what language you're trying to translate from. And again, like all our other services, you'll find this very cost-effective. So why don't we try and translate our call center example into some other languages? First, let's select this Translate service. We start on the landing page, which gives a brief overview of the features, as well as some sample use cases you might like to use the service for. Next, we click on Getting Started. As we are just doing a single example, we can paste our call center transcription right here into the console. As I am based in Singapore, and Chinese is a common second language, let's change our language pair to English-Chinese. You'll see that we get an instant translation, and we can see that the raw output down below. You'll notice the system has also detected both the seat 1C and Gabe's name as entities not to be translated. We can also change our language pair. Here we have chosen German, then Spanish, and the translation is instantly applied. Now we can have global reach with our translated text. Why don't we jump back into our example and summarize our use case. Here I've distilled transcribe audio into a more display-friendly version. You can see the accuracy of the punctuation and also the flow of the conversation. If we apply the steps of our Amazon Comprehend service, we can break this down into its raw parts. Our first step is to isolate any entities. This will allow us to understand the context of the conversation. In this example, we can see that Gabe is the requesting entity, that the time we want to take the action is tonight, and that the object we want to influence is our flight and our seating arrangement. But we're still missing key parts of the conversation. If we add in our key phrases as a second step, we get a much clearer picture of the nature of this call. We know we are dealing with a flight, that we are after a seat upgrade, and also that this person is a platinum member, so is likely to get preferential treatment for this request. But what about the general tone of this conversation? How is our customer service person doing? How is the customer feeling? When we analyse the sentiment of the call, we can clearly see in the last line that this customer is happy with the interaction. In fact, we know from our demonstration that this call had a 63% happiness confidence. But what if the customer wasn't having such a good time? Here we see that Gabe has not been detected as a platinum member and therefore is not getting an upgrade. This call is not giving the customer outcome and therefore the sentiment is over 50% negative, ending in a frustrated customer. It is engagements like these in the millions of calls that service centres receive that we could use to find unhappy customers. If we did want to transcribe, index, translate and comprehend 1 million calls, how would we architect such a system? First, we gather our audio and place it in our simple storage service, S3. S3 has a built-in event handler that can fire a function in response to a new audio file being uploaded. This function runs under a service called AWS Lambda, which will then call the transcribe service to perform an analysis of our audio. This will output a transcript. From there, we can use the output of transcribe to feed the comprehend service, which with our topic modding feature. This will process thousands of calls to create a corpus of data that will allow us to detect customer trends. Now, our business analysts and data scientists can use Amazon Athena to run ad hoc queries across this index data. And finally, we can visualize the results using Amazon QuickSight, our business intelligence and reporting service. Using this architecture, we are limited only by the amount of data and audio we have recorded. So I urge you, unlock the data that is inside your audio recordings. Gain customer insights from it. Use it to spot trends in your social media, audio and your video processes. Respond to customer events and help your customers have a better experience. I am Sean Ray. That is Intelligent Language Processing. Thank you very much. If after today you are wanting to take your AWS knowledge to the next level, you have several options available to you. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Additionally, you can attend our instructor-led classes led by qualified AWS instructors and learn how to design, deploy and operate highly available, cost-effective and secure applications on AWS. And finally, don't forget to validate your technical expertise with AWS and use a practice exam to help you prepare for your AWS certification. Finally, I'd like to thank you for attending this session today and sticking it out until the very end of the presentation. Please take the time to provide feedback on today's event so that we can improve the event experience for you in the future.
Hi, I'm Carrie-Anne and welcome to Crash Course Computer Science. Last episode we talked about computer vision, giving computers the ability to see and understand visual information. Today we're going to talk about